things that we did talk about in 3.4 and 3.5. The only thing that we talked about that you could think of like a formula is when we check to see if something is odd or even. It's a single test, and we're going to substitute what in?
Zero.
Not 0.
Negative.
Negative x. We substitute negative x in, and after we simplify, if the equation is exactly the same as it was before, that means it's an even function. If we take negative x and we substitute it in, and we simplify it, and we get the same thing that we would have gotten if we just multiplied the original equation by -1, then it's odd. And if it's neither one of those, then we would say it's neither even nor odd. Okay. When we started 3.4, definition of a function, we talked about what something is to be a function. How do we know if something is or is not a function?
Every input has an output.
Every input has one output. Because we want to use functions to make predictions, and so if I feed it an input and it spits out 2 different things, I can't make good predictions with that. When we have a graph, we can use a visual check to see if something is a function. If I had a graph that, say, looked like this, I can check my inputs and my outputs using a vertical line. So anywhere I would draw a vertical line, because vertical lines go through my x-axis, right? If I draw vertical lines on there, I should only have 1 point, because it should only be 1 y for each of those. What about something like a circle? Would that be a function? What about a semicircle? Yes, as Anne knows. What about this kind of semicircle? Yes, that kind of a semicircle would be a function. What about that kind of a semicircle? That one is a no. So some of our semicircles are, if it's a top or a bottom. But the left and the right are not, because if I draw a vertical line here, it has 2 different y values, but the same x part of the ordered pair. 1 input, 2 outputs. We did evaluating of functions. So like if I give you a function rule, I'm just going to make one up here. If I said f of x is equal to 3x squared minus 7x, we evaluated that. And I would say evaluate. What do you do with that?
Put 3a squared for x.
Yep, put 3a plus 2 in both spots for x. And then you simplify it as much as possible. We talked a lot about domain and range as well. To find the domain for things, I want to express all the possible things that x is allowed to be. What is x allowed to be in an equation like this? Just 1?
All real numbers.
All real numbers. I can take any number I want to and I can square it. I can take any number I want to and multiply it by -7. There's no restrictions there. What about if that was on the bottom of a fraction?
All real
Can't
numbers
be
except for 0.
Can't be 0. So I would need to factor that to figure out the values that would make my denominator 0. It's not that x can't be 0. It's that my denominator can't be 0. What about if I had something like this? What would I need to do to that? I would need to factor it. I don't know if this one actually factors. I'm just throwing numbers up there. But I would need to factor it first so that I would be able to find the values that would make the denominator equal to 0. What about if I had this?
In the denominator?
Nope, just that.
Any number.
Negative. Negative.
Can't have negatives under the radical. Could x possibly be a negative number? Yeah, like in something like this, x could be a negative number, but I can't have that expression be a negative number. It'd have to be greater than or equal to 0. Caleb, this is going to where you just were. What about if that was in my denominator? Can't be 0 or negative now. If it's not in the denominator, it just can't be negative. If it's in the denominator, it can't be 0 or negative. What about this? Can't be 0. How would I express that? How would I write that using interval notation?
Negative infinity to 0, and then I use 0 to infinity.
Yes. It can be any kind of negative number all the way up to 0, but I'm not allowed to touch it. It can't be exactly 0, so I would have a parenthesis. I would start it again at 0, but with a parenthesis, because I'm allowed to get really close to 0, but not actually 0. And then any kind of positive number after that.
You put a union in between the two, right?
Yes. Yep. Anytime there's something I have to leave out or there's a gap, you would use a union. We talked about graphs of functions and identifying domain and range and evaluating things.
Question.
Yes.
What technically, wouldn't that gap be infinite? If we're talking about all numbers, all real numbers. Well, not all real numbers. Yeah, all real numbers, like 0.1.
So if we talk about if we say that the domain is all real numbers, that means there couldn't be a gap on there.
Well, so sorry.
Mhm.
Going back to the negative infinity to any like
All the way up to 0, and then
that gap in between there, like wouldn't there technically like be an infinite amount of numbers you can put in there? This has nothing to do with this.
Yeah, no, I think I understand what you're saying. I just want to clarify. So if I write something like that, is that still an infinite amount of numbers?
Yeah, because you can't go exactly to 0 on there, right? Like you can go to 0, you go to like negative 0.0.
Mhm. So another way to express this idea, which we don't have notation for right now, is to say this is all real numbers except 0. So it is an infinite amount of numbers, except there's one number in particular that we're like, you, not allowed.
I do never reach there, right?
Yeah, you can never reach 0. You can reach everything else, but you can't reach 0. Yep. We talked about domain and range on a graph. How do I use a graph for domain and range? Like if there's not arrows on the end. Yep. Domain is from here to here. What do I use for my range? Yeah, my y's, top and bottom. So here to here. If there's gaps, you're going to need a union. We talked about increasing and decreasing. How do I know which is which? Yeah, increasing, decreasing, increasing, decreasing. So far, so good? Okay. If I wanted to evaluate this is some function f, and I said find f of 5. Is this an input or an output, an x or a y? Yeah, this is an input, an x. So I'd look at my x-axis, 1, 2, 3, 4, 5. There's my point. So maybe this is 5, 10. So I would say that f of 5 equals 10. If I turn the question around, though, now what is this 5 telling me? Output, y. So now I'm not looking here. Now I would be looking 1, 2, 3, 4, 5. I'd be looking here. Things that have a y value of 5. How many things have a y value of 5 if I hadn't drawn that crooked?
1.
2. 1 right here. And where else?
So wait, that part right there is a
So
Well, that's the X. Oh.
yeah, here's my input, here's my output. So that would go for this one, input, output. If they're telling me that the y, the output, needs to be 5, now I'm going to use a horizontal line because I want to see anywhere on there that it has that height, because it would have the same y value, the same output for different x's. This is the one where we would do things inside curly braces, because there would be more than one x value that made that output. So like 3 and 6 is what it looks like when I look at this graph. 1, 2, 3, 4, 5. That looks like it's at about 6. So an input of 3 has a y value of 5. An input of 6 has a y value of 5. So far, so good? Okay, again, I'm just trying to do a brief recap of what we talked about in 3.4 and 3.5. Yeah, definitely make sure you look through your notes. Know how to graph transformations. Your parent functions, that library of functions. I gave you guys the handout yesterday, but it's gone over in the video from Tuesday. Make sure you know the patterns for those parent functions, because the more you get those patterns down, the faster your graphing is going to become. All right, Pedro, did you have your hand up, dear? Okay, got it. All right. I'm going to go ahead and get us started on 3.6. And if you guys still need to know exactly what it is that you need to study for or things that you need to pay attention to, I'm happy to talk about that closer to the end, okay? So 3.6. We want to find the standard equation of any parabola that has this as its vertex. So standard equation, this is vertex form. Vertex form is y equals a times x minus h squared plus k. When I look at vertex form, where's the vertex? That's when I'm looking at the graph. When I'm looking at the equation, how do I find the vertex? HK. Beautiful. Here where it says I want this to be true for any parabola, well, they gave me a vertex, so which pieces are definitely decided? H and K. Here's H, here's K. So all of these parabolas have to have the same vertex. So what's allowed to be different about them if they have to have the same vertex? The A value is allowed to be different. It might be narrower or wider. It might be reflected. We're going to let A stay A in the equation. That's how it will work for any parabola with this vertex. So I'm going to write y equals, I need to keep the A there so that it works for anyone. What would I have inside my parentheses?
X plus 3 squared.
Yep.
Plus 1.
X plus 3 squared, and then plus 1. Why is the x positive and, or sorry, why is the 3 positive and the 1 positive?
Because you changed the H, right?
We change the x. How do you know when to change it and when not to change it? Where is the 3? If you were given directions to my 5-year-old, you would say the 3 is where here? Like if she didn't even know what a 3 looked like. Inside the parentheses. Anytime it's inside parentheses, that's when we see our signs change. If it's not inside parentheses, the sign does not change. So So this is what I would have for this one. Choop, choop, choop. Done.
Well, I don't know why.
Mm-hmm.
For some reason, like, so I'm retaking semester 1 of algebra 2 right now.
Mm-hmm.
And PreCal and algebra 2 go hand in hand. Like, we're doing like the exact same stuff. So
Mm-hmm.
it's translating. Like, we just learned it. That's all scared.
There's a lot, so you're not wrong. Actually, the whole first semester of pre-calculus is like an extension of algebra 2. There's so much material that is technically considered algebra 2 that they had to extend it out into a whole nother semester.
Dang.
Yes, sir.
What's the hardest math, like,
In
in this school?
this school,
Yeah.
depends on the person, but I would go either calculus BC or statistics, depending on the person studying it, depending on their strengths and weaknesses.
So what, like, what's the difference between statistics and, like,
Statistics is less algorithmic, less computation-based, and more interpretation. So people that tend to do really well in like English classes tend to excel in statistics classes. You learn how to do the computations, but a lot of times in statistics, you're working with so much information that you'll actually have software do the computations for large data sets. But then what it spits out, you have to know what it means, how to interpret it, what can you do with it from there, and how do you know? So depending on the way your mind works, some people are like, oh, well, I can do that all day long. And other people are like, can you just give me a formula and I'll work the formula? So, alrighty, this one, standard equation. So again, we're doing vertex form. And it needs to work for any parabola. And here's my vertex, so I have my HK. So what is this going to look like?
1 equals x squared minus 2.
Y equals A.
Y equals A, so that it works for any parabola.
X squared minus 2.
X squared minus 2.
Did we put an A for the last one?
We did.
Oh.
Yep, right there, in front of the parentheses. Why don't I have parentheses here? Yeah, H is 0. It didn't go left or right. So I don't need parentheses around it because there's no movement there.
what if you leave the parentheses zero?
Like this, I would accept that. That's not wrong. Yes, sir.
If you wrote the zero, like, would you count that wrong?
Nope. If you have y equals a and then like x minus 0 squared minus 2, I wouldn't count that as wrong. It's not fully simplified, so if the directions say make sure to fully simplify your answer, then it wouldn't be fully simplified. But if the directions don't say that, if it just says write an equation, that's an equation. Satisfies the parameters given. Okay. You guys okay with this so far? Cool. I want to write f of x in this form right here. Same form we've been working with. What do I have to do it with?
Quadratic.
Yep. What form is this in right now?
General.
General form. How do I take something from general form and get it into this form? Complete the square. We've done completing the square quite a few times already. We've solved by completing the square. We used it a lot with our circles. When I'm doing it with parabolas that we're going to write using function notation like this, I do it a lot like I do with the circles. Do you guys remember the first thing we did was we took our constant and we kicked it to the other side? That's what I'm going to do here too. And in fact, I'm going to totally ignore my function notation until the end. I'm just going to like forget it's there. I'm going to kick that c value to the other side. So I'm going to add 5 to both sides. It's just so I can get him out of the way. So I would have 5 equals negative x squared minus 4x. Do we have an a value?
Yes.
Yes. What is my a value?
Negative.
-1. So I have to get that out, and we kick him to the front. Do you remember doing that?
Yes.
Okay. So on this side, I know I'm going to be adding something over here. If I have to kick an a value out to the front, that's going to get multiplied to whatever I add over here. So I'm going to have x squared plus 4x plus something so that I get a perfect square trinomial. How do I find what goes on that line? 4 divided by 2, and then we square it. So what do I have? 4. I put that here and here. All right, so I have 5 minus 4 over here. I have negative. How is this going to factor?
X plus 2 squared.
Yep. X plus 2 squared. This right here is always going to be b cut in half, but before you do the squaring. So half of 4, that's where we got that from. Can we simplify this?
Yes.
What is that?
1.
1. All right. I'm going to bring my work over here. So I have 1 equals negative, and then x plus 2 squared. Now I'm going to bring that value back over because that's my k value, and then I can use my function notation again. So how do I get 1 to the other side? Subtract it. So now I can write my function notation, f of x equals negative and x plus 2 squared minus 1.
We put it as y equals, would you count that wrong?
I would not. The directions technically said express f of x, but function notation, unless we're working with multiple different named functions, I don't really care. If we had a lot of different functions, f of x, g of x, k of x, I don't just want to see a bunch of y equals, or we're not going to be able to tell them apart. Where's the vertex for this guy? -2, -1. Would it be a maximum or a minimum? How do we know?
Because the a value is negative, and that means it's going down.
A value is negative, which means it's concave down. So is the vertex the topmost point or bottommost point? Topmost. So this is going to be a maximum. All right. So far, so good? Yes, sir. How we knew it was a maximum?
Yep.
Absolutely. So do you see this thing right here? That means when A is negative, my graph opens down. So without actually drawing the whole graph, I know that it would have this shape to it, not the other way. Here's my vertex, top or bottom. That makes it a maximum. If it was turned around the other way, if it was like this, then the vertex would be the bottom, right? That would make it a minimum. Make sense? Cool. All right. You guys ready for another example? Fantastic. We need to put this in vertex form. What do I want to do first? Yep. Let's get that 5 on the other side. So I'm just going to ignore my function notation for right now. And I'm going to kick him to the other side. Do I have an a value that I need to get out?
Yeah.
What is it?
Negative 3.
-3. That's going to come up to the front. And anytime I have an a value that comes out, I'm going to have to multiply this piece by that. So -3, and then I've got my parentheses. That would give me x squared, and then what?
-2x
Close.
plus 2.
Plus 2x plus something to make this a perfect square trinomial. What do I need on my line? 1. 2 divided by 2, and then squared. So I have it here and here. So over on the left, I have 5 minus 3. On the right, I have -3, and then how does this factor? X plus 1, quantity squared. How does the left hand simplify? 2. I want to get that to the other side though, right? So what do I need to do? Subtract it from both sides. And then I can rewrite it with my function notation. So f of x is equal to -3 times x plus 1 squared minus 2. Where is the vertex? -1, -2. Tell me this one's coming for you, dear. You ready? Is that vertex a maximum or a minimum? Maximum. How do you know? Yep, negative a value right there. So this is a maximum. Let's do one more like this. I want to make sure that everybody has a chance to get this written down before I put the next example up. Are we good? Okay. It is not as bad as it looks. What would my first step be? Subtract the 23 over 5 from both sides. So it's going to cancel out here. And I now have it alone on the left. All right, everybody hates my fractions. Do we have an a value that we need to get out? What is it? 2/5. Got to come out of both pieces. So I'm dividing both of these by 2/5 so that I can kick it to the front. -23 over 5 plus something that gets multiplied by 2/5 is equal to 2/5. Well, the first part's easy. That's going to be x squared, right? Do I have a plus or a minus after that? Minus. Okay, so now let's look at this. I have 12 over 5, which is a fraction, being divided by a fraction. How do we, what do we do when we're dividing by a fraction? Multiply by the reciprocal. So what do I get when I multiply by the reciprocal?
-5. Oh wait.
6, because I get 60 over 10, right? Which gives me 6. Or some people look at it and they cross cancel and they just do 12 divided by 2. So I have x squared minus 6x plus something. That doesn't look quite as scary anymore. Yes, ma'am? What's going to go on my line? 9. Negative 6 divided by 2, and then I square it. So 9 here and 9 here. So I have negative 23 over 5 plus 2/5 times 9. 2 times 9 is 18. So I have 18 over 5 equals 2/5. And then how is this going to factor then? X minus 3 squared. Do I have a common denominator here?
Yeah.
Yep. Negative 23 plus 18? Negative 5. So I have negative 5 over 5, which is the same as what? Negative 1. So I have negative 1 equals 2/5 times x minus 3 squared. So what is my vertex form? Not my vertex. What is my vertex form?
2/5 x minus 3 squared plus 1.
Beautiful. Was that as bad as you thought? Pedro, where's my vertex? 3, 1. Yep, 3, 1. Tell me, is that a maximum or a minimum? Minimum. How do you know? Yep. A value is positive, so if I were to graph this guy, it's going to look like this. We doing all right? Awesome. I want to draw some sketches that include the maximum or the minimum and the roots. We're going to use quadratic formula to find the zeros. Give me synonyms of zeros. Roots. Give me another one. X-intercepts. Give me another one. Not factors. Starts with an S. Solutions. I want my solutions. And then I also want the maximum or the minimum value. This is why I was going over maximums and minimums on the last one, or those last few. All right, quadratic formula. I always like to do the discriminant first. The part underneath the radical. I do b squared minus 4ac first so that when I substitute into the formula, I'm only plugging in 3 pieces. If you do it differently, but you get the same output as me every time, you keep rolling the way you like it. If I take b and square it, 4 squared, minus 4 times a, which is 1, times c, which is 9. So I have 16 minus 36, which gives me what? Negative 20. That's going to go underneath the radical. So what do I know about my solutions here? Not real. We're going to have 2 imaginary roots. All right, so I have x equals negative, and then I substitute in my b value, which is 4, plus or minus the square root of negative 20 all over 2 times my a value, which is 1. Can we simplify that radical at all? What would it be? Yep. Ooh. 2 square root of 5 I. Because this is 4 times 5 times negative 1. Can I simplify that at all? Yep. I can divide all three of these by what? By 2. So my roots, my zeros, are -2 plus or minus the square root of 5i.
Is that I outside the radical?
Yes, the I is outside the radical. Good question. I should probably scoot him over a little bit more. Maximum or minimum means I need what? How do I find my vertex? What did we just do to find the vertex?
Complete the square.
Complete the square. So we're going to complete the square here. Yes, sir.
So, if we can just complete the square to find the roots,
Nope. We couldn't complete the square to find the roots. We're completing the square to find the maximum or minimum, the vertex.
well, we couldn't we complete the square to find the roots? Like eventually, couldn't we solve it enough?
Yes, you can complete the square to solve it. Yes. The reason we didn't do it on this one is because it specifically said to use quadratic formula.
Okay, yeah, that's where I was getting at. So
Yes.
if we
Mm-hmm.
would it be wrong if we did like the entire thing just only using completing the square? Because this would mean like we have to do the quadratic formula and completing the square.
If the directions say that you need to use quadratic formula, then that's what I would need to see, because that's the evidence that I'm looking for. But if it just said find the zeros and the maximum or minimum, then you could use completing the square for that entire process.
Gosh.
Yep. So what do I need on my line? 4, because I do 4 divided by 2 squared. So 4 here and 4 here. So this is going to be -5 equals, how does this side factor? X plus 2 squared. So what is my vertex form then? Close. +5. Why is it +5? Yeah, I got to kick that 5 back to the other side. Okay, so where is the vertex? Vertex is -2, 5.
You still want us to put A up there? In the,
Oh, in front of it? Only if it says for any parabola. So is this vertex a maximum or a minimum? Minimum. If the input is -2, that's how I get the maximum, or sorry, the minimum output, right? What is the minimum output going to be? 5.
Wait, why -2?
just the extra
Mm-hmm.
vertex.
Where did the -2 come from again?
Yeah.
Right there. Because my ordered pair tells me input and output. If I put -2 into this function, it gives me my minimum value, which is 5. Yes, ma'am.
So when we're asked to find the minimum value, do you want to start it as the equation and not the point?
So you would tell me, like if it said find the maximum or minimum value, the way it's set up in Canvas right now, you have to select whether it's a maximum or a minimum first. And then it has F, and you're going to tell me what goes here. That would be the X part of your ordered pair. And then what's your output? Yep. All right. I'm going to stop us there for right now because with all the craziness that has happened over the last however long, I never had a chance to show you guys your last quiz. So I didn't see you, and then this and that, and too much has gone on.